1.6, function operations and composition of functions. So we start out with looking at how you can find the sum f plus g of x by just adding those functions. Difference, so I can just take my two functions and subtract them. So I feel like this part's pretty straightforward. So we just need to remember that operations means add, subtract, multiply, and divide. That's what this page is. Composition is when we're using one function as input for another. And of course, we don't have that on this page. We'll look at that on the next page. So for number 1, we're given three functions, f of x, g of x, and h of x. And then we're asked to do all these different things, g plus h of x, g minus f of x, g times h of x, and then f minus g of x. And we're also going to give the domain. We need some practice with that. Domain, that looks like demon instead of domain. There it is. Give the domain. So for our first one, when we do g plus h of x, we know we're just going to take those two functions and add them. We'll take g of x and add h of x. You don't really have to write that part. I think it's just good for our notes. So g of x is x squared minus 2x plus h of x is 3x minus 4. And then we're just going to go through. The parentheses aren't really doing anything. I'm not distributing anything, so I'm just going to put my like terms together. So x squared plus x minus 4. And I know if I have something like a parabola, I can plug in any number. So I would say that my domain is negative infinity to infinity. So with domain, we have to worry about square roots. We have to worry about fractions. So g minus f of x means I take g of x and I subtract f of x. So I know that g of x is, and I guess I could look over at my paper over here. So g of x is x squared minus 2x minus, and then f of x is negative 2x squared plus 1. So now I need to distribute that minus sign. So x squared minus 2x plus 2x squared minus 1. And we'll just put like terms together again. And again, there's no square roots, there's no fractions, so there's nothing I have to worry about for my domain. It's just x squared means I have a parabola, so I can plug anything in for a quadratic. So my domain is all real numbers or negative infinity to infinity. We're still working with that interval notation. Remember, these are our x's, so x can go all the way from negative infinity to positive infinity. It's our beginning and end for what x can equal. So let's go ahead and pop up the screen and we'll make a little more room for the next one. Let's see, the next one was g times h of x, which means g of x times h of x. So let's see, g of x was the x squared minus 2x. I can see that right there. And then times, so now I need to go ahead and scroll up. Let's see, h of x, 3x minus 4. Really, I don't need that dot there. So now I need to go through and distribute. So let's see, 3x cubed minus 4x squared minus 6x squared minus 8x. And then we'll put our middle terms together again, 3x cubed minus 10x squared minus 8x. And again, there's no fraction, there's no square root, so I know that I can have any real number for x. So my x's will go all the way from negative infinity to positive infinity. My last one is a division one. So I'm going to go all the way up to the top and just work that one on the right. So f divided by g of x. So that's going to be f of x divided by g of x. So my f of x is negative 2x squared plus 1. And my g of x is x squared minus 2x. So I can tell already with that denominator, right, there's going to be some things that I can't have. So I'm going to go ahead and factor that. And usually most of us can just look at it in that form and we can tell right away what numbers we can't have. But if you're unsure of how to do this, our method is really that we're just letting our denominator equal 0. To find the restrictions for x. Right? We're trying to find what numbers we can't have for x. Sometimes I just call it the bad x numbers. So if I have x times, and again, you don't have to show this, you can just look at this, but some of us need to remember where it comes from. So x is 0 or x minus 2 equals 0. So x is 0 or x equals 2. And so if I'm thinking about this on a number line, I can't actually be 0 and I can't actually be 2, but x can be everything else, right? So I can go from negative infinity up to 0. I can't actually be equal to 0, but it can go from 0 to 2, and then it can go from 2 to positive infinity. So let's go ahead and we're going to put this up at the top, kind of in the middle there with the problem for my domain. So my domain is from negative infinity to 0, union from 0 to 2, union from 2 to infinity. Barely fit that guy in. So we're just really working on interval notation. Again, these intervals, this is like my beginning and my end for x. So it doesn't say anything about y's. When we talk about domain, we're talking about x's, and that's not an ordered pair. It's not an xy. It's where my x starts and where my x ends. So next we're going to look at composition of function. We did those function operations. Now we're doing composition. These are all different ways that you can write this f of g of x. This is probably what we did last year that's familiar to you. This one's real simple. You're going to see that in the book a lot. These are all the same. So normally what I do when I see f of g of x, and a lot of kids will just call this fog, which I think is kind of cute, is I will just rewrite it right away as f of g of x like this, because I think this really clearly shows that the g is first, it's inside. So that means I'm taking all of g and I'm substituting it into the second one, well, sorry, and I guess the outside one for all the x's, okay? So I'm finding f of that square root of x plus 2. So I'm taking the square root of x plus 2, and that's replacing all of my x's. So that means instead of x squared, I would have square root of x plus 2 squared, right? Quantity squared, plus 6 times, instead of x, I would have the square root of x plus 2. And then I would need to go ahead and simplify that. So here I have a square root and it's being squared, so that's just going to be x plus 2. So remember, if we have, let's go down here and use a different letter. So if I have the square root of, I don't want to use x, let's use w, and then I square it, it's just equal to w, because my square root could only be something positive to be square rooting it. But if I have w squared, and then I want to square root that, I want to just make this a square root on the outside. I don't know if w was positive or negative to start with, so it has to be an absolute value. So that's something we just always kind of need to remember. So going back and finish simplifying here, I have x plus 2 plus, and then this is just 6 times the square root of x plus 2. And remember, we talked about how for square roots, we can't square root negatives. So the part inside the square root always has to be greater than or equal to 0. So that would mean I have x plus 2 greater than or equal to 0, which would mean x is greater than or equal to negative 2. And I don't need to see the work for all this part, but On our notes, remember, we're trying to show extra detail so you remember how you got something. And again, I'm going to look at this on a number line. This means I would start at -2. It would be a filled-in circle. It would go to the right. So my line goes from, my ray, I guess it is, goes from -2 to infinity. And so when I write this in interval notation, my domain will be -2, and it would be a hard bracket, not parenthesis there, comma, infinity, because I'm actually equal to that -2. Sometimes it helps to graph them out and look at it as a number line first. So the last thing that we're going to do, and this makes it kind of a step harder than what we did last year in Algebra 2, besides just the focus on domains and interval notation, is we're going to decompose. So that means we're going to break apart a function. So we're going to take a function and pretend it's f of g of x. We're going to break it apart and go back and identify f of x and g of x. So we're going to write f and g such that h of x equals f of g of x. And we're going to have to come up with the f of x and the g of x. So we're going to identify what f of x is. We're going to identify what g of x is. And there are multiple answers here. There's going to be an answer that's straightforward and easier that most people will come up with, but there are multiple answers. So when we're going through to kind of break apart a function, the way I'm doing it is I first, instead of h of x, I'll think of f of g of x equals this 1 over x plus 2 squared. And I know that my g of x is that part that's inside. And so I want to look over on the right, and I want to see if I can identify a part that could be inside on the other function. And for me, it looks like this x plus 2 squared. So it looks like 1 over something squared, right? And so I would let the g of x, and it is kind of weird. There's not really any work to show on these. I would let the g of x then equal that x plus 2. And then my f of x would just be 1 over. So I want to write that something was being squared, and I would put that x plus 2 in for it. So this is just going to be an x squared. So that's going to be my guess. Now I always want to check my answer on these, okay? Check my answer. So if I am finding f of g of x, that means I'm doing f of x plus 2, right? G of x is x plus 2, and that means I put the x plus 2 in for wherever x is in my function. So that would be 1 over the quantity x plus 2 squared. So it works. So I'm going to go ahead and box in my answers. So again, there's lots of different steps. You could write that g of x was x plus 2 squared, and then this would just be 1 over x. There's a lot of different ways to set these up. So I am sure in class we will do extra examples of these decomposition of functions so you get the hang of it. But these are our notes for today.